Okay, this is the fourth video in the playlist that deals with Lewis formulas, and what we're going to do is practice more structures. And what I want to start with is going to be the diatomic form of oxygen. Now, what makes these practice molecules different than the ones that I did in the previous couple of videos is that they're going to have multiple bonds in the molecule. And what I want to, one of the primary things I want to demonstrate in this video is how you use the steps to let them lead you to the correct structure. All right, and you'll see what I mean as we get into this. So let's look at oxygen first, diatomic oxygen, and following the rules or the steps, the valence of oxygen is its group number is 6A, so its valence is 6, and since there are two atoms in diatomic oxygen, that means we're dealing with a total of 12 electrons. This is our magic number. These are the valence electrons that when it's all said and done, we will have had to use these up. So following the steps, step number 2, we draw the skeleton structure. All right, and since there are only two atoms, we just put them side by side. Now, following the steps, the next thing we're going to do is connect the atoms. All right, and so here's a bond. All right, and quick count, we've used 2 electrons. That leaves us 10 to go. So following the steps, I'm going to go ahead and put in my unshared pairs so that each of the oxygens will have no more than 8, right? We're going to use up the electrons as unshared pairs following the steps. So we go ahead and put them in like this. We're not really thinking too hard, we're just doing it. And we use up the electrons, right? So we've got enough unshared pairs on each oxygen. So counting the bond between them, there's 8 electrons around each oxygen. Now we go to the test, step number 5, and the first thing we do is count the total valence, the total electrons we use. So it's 2, 4, 6, 8, 10, 12, 14. Okay, we automatically know following the steps that this structure is incorrect. So we start over. We put the 2 atoms side by side. Now, oftentimes students ask me, how do you know that there's a multiple bond? Well, if you let the steps drive what you do, you can see that what's going to happen next is that they actually lead you to the correct formula, the correct structural formula. Because we need to do something different now than what we did over here on the left. Because we don't want to just repeat the same mistake over and over again. So here's a key thought in this. All right, so by adding a multiple bond total electron valence is reduced. All right, the total electron count. So here's what I mean. So we go in here to step number 3, and we put a bond in, and now what we're going to do is we add a second bond. All right, and our quick count is a total of 4 electrons. I'm going to put that over here out of the way. 4 electrons. All right, and so that leaves us 8 to go. So I'm going to go ahead now and put in my unshared pairs following the same rules. So I put in only 2 unshared pairs on this oxygen now because again, we cannot have more than 8 electrons around the oxygen. So we count 2, 4, 6, 8. We need to count both of the bonding sets in here. So we're done with this oxygen. So now we got to come over here to this one, and we add our 2 pairs over here so that we don't exceed 8 around that one. Now we do the total count. 2, 4, 6, 8, 10, 12 electrons. So we see that the total valence, the total electron valence that we have in our molecule equals the magic number. All right, so now this molecule is past test number 1, or test A. Test B is we need the octet around each of the oxygens. We already know that we have that because we went through this when we were determining whether, how many unshared pairs to put on each of the oxygens. But let's count again. So we're going to have 2, 4, 6, 8, 10, 12 electrons. We have 2, 4, 6, 8 on this oxygen, 2, 4, 6, 8 on this one. So this is the best structure. All right, now let's look at my next example. And for that one, what I want to do is we're going to look at nitrogen, which is another diatomic molecule. All right, its valence is 5. All right, so we do our count. It's going to be 5, and there are 2 nitrogen atoms in diatomic nitrogen for a total of 10 electrons. All right, we place the atoms side by side for the skeleton structure. All right, and we come in and we do our connection. All right, and we've used up 2 electrons, so the remaining electrons are going to go in as pairs. I'm going to go ahead and do that, and I'm going to do it in a mindless way. I'm not going to sweat anything here, I'm just going to do it. And now I'm going to test the structure by counting the total electrons. 2, 4, 6, 8, 10, 12, 14 electrons, but we only have 10. This structure is wrong. I let my steps drive what I do, so I'm going to write my 2 ends again. And like in the oxygen, I'm going to add a multiple bond. Then I'm going to come in and I'm going to add my unshared pairs, not to exceed 8. And I'm slapping myself on the back. I'm a happy camper. Now let's go ahead and count the total valence. 2, 4, 6, 8, 10, 12. Oh my gosh, wrong structure. So I put my 2 ends again. And I'm just following these steps. See, I'm following the steps straight through, and I'm letting them tell me what to do. Now, here's the key thing right here. I understand already that by adding multiple bonds, I can reduce the total valence electron count. So I add another bond here. And now I place my remaining electrons as unshared pairs. Whoops. Hang on one second. Teacher's glitching. Now let's do our quick count. 2, 4, 6 electrons. I'm going to write that over here. 6 electrons, and that means I've got 4 electrons to go. Now remember, when you place the unshared pairs, it needs to be done so you don't exceed 8. So here's an unshared pair, that's 2, and then we need to count in or sum up the total bonding too. So it's going to be 2, 4, 6, 8. So I can only put 1 unshared pair of electrons on that end, and that means over here I can only have 1 unshared pair here as well. So now I do my count. All right, I've got 2, 4, 6, 8, 10 electrons. So I've hit that magic number. I've hit the magic number, so I know this is a good structure. Is it the best one? Do part B, which is make sure I've got my octet. So I've got 2, 4, 6, 8. And then I've got 2, 4, 6, 8. So this is my best structure. All right, now I think we have time for one more example in this. And the one that we're going to do, we're going to expand this to a little bit more complex of a molecule. So let's look at carbon dioxide. This has 3 atoms in it. So applying the rules, first off, look at the carbon. All right, we need our total valence, and it's in group 4A, so it's going to be 4 plus the oxygens, and O is coming out of group 6. So there are 6 valence electrons. There are 2 atoms. So we have 6 times 2, which is 12, and then that will be added to 4, so we have a total of 16 electrons. All right, now we draw the skeleton structure. So we're going to have O, and then the carbon is the central atom, and then we're going to have an O. All right, and following the rules, we go ahead and bond the carbons. And then we need to put in unshared pairs as the next step. So I'm going to go ahead and do that, starting on the central atom. Moving out. Making sure I have 8 on every single atom. And now I move to the testing stage. I'll use red for this one. And go ahead and count. So I've got 2, 4, 6, 8, 10, 12, 14, 16, 18, 20 electrons. Magic number is 16. This cannot be right. So I move to another mode. I'm going to go ahead and put a double bond between the carbon and one of the oxygens. All right, and now I'm going to go ahead and put in my unshared pairs so that everybody's got 8. They start with my central atom and then I move out. And now I count. So let's see, we got 2, 4, 6, 8, 10, 12, 14, 16, 18. Incorrect. Notice all I'm doing is I'm letting the steps work for me. I'm letting the steps work for me. I just roll the steps is what I'm doing. All right, so let's try this again. Remember, adding multiple bonds reduces total valence count. So I'm going to do this. All right, and now I move to step 4. I'm going to place my remainings so as not to exceed 8. And now I do my total count. 2, 4, 6, 8, 10, 12, 14, 16 electrons. All right, I hit my magic number. So this is a highly probable possibility. Now I go to part B. Do we have the octet? 2, 4, 6, 8. Good. All right, I look at my carbon. 2, 4, 6, 8. Good. And then I look at this oxygen. 2, 4, 6, 8. Awesome possum. This is the best structure. All right, we're going to close here and we'll go to another practice video.